Hello students, in this video, we will be solving problem sums involving us to find the area under the curve. So do get ready a pen and some papers and practice along with me. What is considered area under the curve? It could be an area of a region above the x-axis. What is important is the area must be bounded. So in the example I've just shown you, the area is bounded by the curve y equals to f of x, bounded by the two vertical lines x1, x2, and also the x-axis. So to find the area, we can integrate y respect to the x, taking limits from x2 to x1. What happens if the area of the region is below the x-axis? So if you look at the area that's shaded in yellow, it has to be bounded by the two vertical lines x1, x2, x equals to x1 and x equals to x2, the x-axis, and also by the curve y equals to g of gx. And to find area of B, right, you have to include a negative sign in front of your integrals, because the answer you'll be getting for finding B will be a negative values. And since we are talking about areas, finding areas which is supposed to be a positive value, we will need to include a negative sign here to negate our answers so that we will arrive at the positive value. Supposing we are asked to find the area of a region that's between the curve and the y-axis. The curve that we're interested in, it's bounded by the curve x equals to g of y. Bounded by the horizontal line y equals to y1 and y equals to y2 and the y-axis. And if this is the case, how do we go about finding the area? Yes, so in this example here, the area of A can be found by integrating x with respect to dy and taking the limits from the y-axis. So what you'll be having will be the limits is in terms of y, which is y2, lower limits is y1, and g of y dy. So if you look at the variables, everything is in terms of y, which is different from the earlier example where everything is in terms of x. Let's look at these questions. In these questions, we're asked to find the area of the region that is bounded by the line MN, the curve x equals to 2y squared plus 1, the x-axis, and the y-axis. However, pay special attention to the equations of the curve. It's given to be in terms of y, making x the subject. So that gives us an idea that we will have to take limits from the y-axis. But before we can do that, step number 1 is to find equations of the line MN. Because by finding the equations of the line MN, we can solve it simultaneously with the equations of the curve to find the coordinates of the intersection point, where we call it x. So to find the equations of MN, we need to find the gradient of MN And the equations of Mn to be y minus y1 equals to the gradient bracket x minus x1. And with these two equations, I'm going to substitute equation 2 into 1. Right, substitute 2 into 1. And you would get, yes, y equals to negative 2y squared. Minus 1, y minus 1 because of the negative in front here. So the negative times 2y squared gives you negative 2y squared, but the negative times positive 1 will give you negative 1 plus 4. And if you simplify it further, you end up getting a quadratic equation in terms of y, where we can factorize it and find two values for y. So if you look at the diagram, all right, quite obviously y equals to negative 3 over 2 will have to be rejected, because if you look at the diagram, the y coordinates for x is above the x-axis, which is a positive value, which is y equals to 1. So by substituting y equals to 1 into the equations of Mn that we found earlier, right, you can find x to be, or wait, it's easier to substitute into the equations of the curve because it's already in terms of x. So by substituting inside here, you can easily find x to be 3, which will give us the coordinates of x to be 3, 1. Then the next step is that we can actually find area under the curve from y equals to 1 to y equals to 0. So which part am I referring to? Yes, this is the one that I'm referring to. We can find area, this area, where we can integrate 2y squared plus 1 and taking limits from 0 to 1. And that will give us 5 over 3. And the shaded region actually comprises of the one shaded in red plus the triangle. So the area of the triangle, we can just use half base times height. And adding these two areas, that will give us the area of the shaded region, which is 6 1 over 6 units square. Let's look at the next questions that require us to find the area of this shaded region, where the equations of the curve is a trigonometric functions. Right, so the shaded region is above the x-axis. So what we need to find first is to find the upper limits, find this x coordinate. And to do that, we're going to let y equals to 0. And if you recall how we can solve trigo equations, we're going to find the reference angle, which is sine inverse 0, and that gives us 0. And if you look at what we need to get for our angle x, it has to be a positive value. So for sine to be positive, if you were to recall your ASTC, you come from the first and the second quadrants. So we can't be using alpha to be 0 because you end up getting a negative value for x. Therefore, alpha has to be the second quadrant, which is pi minus 0, gives you pi. So therefore, 3x plus pi over 4 will give you pi. And from there, we can go on to find the values of x, which is pi over 4. Now remember, in the topics of integration and differentiation, the angle that we are managing with the units will always be in radian. So in this case here, x is equals to pi over 4. And we're going to take limits from 0 to pi over 4. Right, so how do we integrate sine? Yes, integrating sine will give you negative cosine. So you will end up getting negative 6 cosine bracket 3x plus pi over 4. And how do I get this 3 here? Yes, you have to divide by the differentiation of whatever is inside the bracket. And differentiating 3x plus pi over 4 will give you 3. The next step is to put in the limits. But before you put in the limits, simplify it. Because negative 6 divided by 3 can give you negative 2. And make sure you do it properly. If you're using your calculator, because you're dealing with angle in radian mode, you have to change the calculator mode to radian. If the questions require you to leave it in exact form, then yes, then this is where you will have negative 2 cosine pi over 4. And pi over 4 is 45 degrees, it's a special angle. And cosine pi over 4 will give you square root 2 over 2. So that explains this part here. Right. And of course, cosine pi will be negative 1. So that explains my negative 1 here. So putting them all together, you get 2 plus square root 2. That is if your answer is asked to be left in exact form. Otherwise, you can just use a calculator to evaluate it to get 3.41. The only thing is that to remember to change the calculator mode to radian. Let's look at the next question. The next question is involving two areas A and B. They have the same area, and we're asked to find the unknown A. Right, so step number 1, let's go on to find the area of region A by taking limits from 1 to A and integrating 36 over bracket 2x plus 1 to the power of 2. Convert it to negative index first. Simplify it. 36 divided by negative 2 will give you negative 18. Always simplify it before you put in the limits. That will make your chances of making error lesser. So 36 divided by negative 2 will give you negative 18. Alright, so your first limit will be A. Second limit will be 1. You can't use a calculator. You have to work this out because that is in terms of A. So how do you get that? This will be equals to negative 18 over 1 times 1 over bracket 2A plus 1 to the power 1. And that gives you negative 18 over 2A plus 1. And of course, you can just use a calculator to evaluate this to get positive 6. So that's area of region A. And area of region B will be, okay, you don't have to work out your integrations again. You can just basically use this part here because we have already done the integration in part I, right? So you can just use this portion here to replace your limits. So in this case here, the limits, replace your A now with 4. Replace your 1 with A because your limits is from A to 4 now. Right, and then you're going to simplify the expression. If you use your calculator correctly, this will give you negative 2. And of course, this one here, you can't use your calculator. Okay, this will give you negative 18 times 1 over bracket 2A plus 1 to the power 1. And the negative and negative will give you positive. So that explains this part here. and both of them will have the same area, so you can just equate them. Simplify it, do a cross multiply, and you will have A equals to 7/4. Right, so sometimes the questions will involve logarithmic functions, will involve trigo functions, will involve exponential functions, will involve anything. So in these questions that we're going to do next, involve a trigo functions. So there are two areas we need to find, okay? This one here, and this. But before we can actually find the area, we need to find the x-coordinates for point A and the x-coordinate for point B. And that involves the concepts we have learned earlier on, that's solving trigo equations. Right, so the alpha, we're going to find a reference angle alpha. Alpha is a positive acute angle. So we're going to cosine inverse half, which gives you pi/3. And under your ASTC, for cosine to have a negative values, it will come from the second or the third quadrant. So therefore, your x can be from the second quadrant with pi minus alpha, which is pi/3. That gives you 2 pi/3. And from the third quadrant will be alpha plus pi/3, gives you 4 pi/3. So the x-coordinate for A will be 2 pi/3, and the x-coordinate for B will be 4 pi/3. So this is the first part that we're supposed to do, part I. So for part 2, we asked to find the area of the shaded region. So we will need to do it separately. Find the area that's between 0 to 2 pi/3 first, which is a positive value because it's above the x-axis. Put in the limits. Alright, and this is what you need to watch out for, because we're dealing with special angle. 2 pi/3 is 120. Sine 120 is equal to sine 60, which is equal to square root 3/2. So 2 times square root 3/2 will end up getting square root 3. Alright, to find the area from 2 pi/3 to 4 pi/3, because the region shaded in red is below the x-axis, always remember that you need to negate your answer, because this answer will come out to be negative. So you need to multiply with the negative to make it positive, because we are managing area. Area is a positive value. Alright, so you do it carefully, properly. Alright, why is this negative square root 3? Okay, because here we're actually finding 2 sine 240 degrees. 240 degrees is actually in the third quadrant. Which under your ASTC, sine is negative in the third quadrant. So that gives us 2 negative sine 60 degrees. And that gives us 2 times negative square root 3/2. That gives you negative square root 3. And that explains how I get the negative square root 3 over there. Alright, then the next step is I'm going to add both area up. And you will get total area to be 3 square root 3. Right, let's look at question 4. So for question 4, we asked to find the area of the shaded region. It's actually bounded by the line PQ and the curve y equals to 2x plus 1 over x minus 1. So to find the area of the shaded region, we should find the area of the trapezium, right? Then minus away the area under the curve, which is this part here, the one highlighted in red. I'm going to show you a different method, and that is a shortcut to what I've just mentioned, where you don't really have to find area of the trapezium and area of under the curve separately. You can just combine them by generating a new equations in terms of x. But before we can do that, we will need to express 2x plus 1 over x minus 1 in the form. Because if you were to examine this fraction we're given, algebraic fractions, it's actually improper fraction. Right, so we have to write it as quotient plus divisor over, quotient plus remainder over divisor. So you can use long division to do it. Or I'm going to show you another way of doing it. And that is 2x plus 1 can be written as 2x minus 2 plus 3 over x minus 1. And from there, I can split it up into two fractions. 2x minus 2 over x minus 1 plus 3 over x minus 1. And this, I can further simplify it by factorizing 2 out. This and this goes off, so that explains my 2 here, which will be the same answer as what you will get if you were to use a long division. Quotient plus remainder over divisor. Right. So we're going to generate a new equations now. So, but before that, we have to find the equations of PQ. So we need to find the gradient. There are two particular points here on the line PQ. You can use point P or point Q. I'll be using point P. Alright, and if you look at the diagram, just now we mentioned that we have to find the area of the trapezium. The area of trapezium is more than the area under the curve. So we're going to use this value to minus away this to generate an equation in terms of x. Simplified it. And with these new equations, I'm going to integrate it and to take limits from 2 to 4. Right. And if you were to recall, when you integrate this, that will give you, this will be 3 times 1 over bracket x minus 1. So integrate this will give you ln to bracket x minus 1. So you substitute in your limits. Right. This questions here, we are not asked to find the exact value. So you can just use a calculator to work out everything to get 0.704. But in case if you're asked to leave in exact form, I've showed you also how you can do it. That will give you 4 minus 3 ln 3. And you can even further simplify it to get 4 minus ln 27. 3 to the power of 3 is 27. Let's look at the next questions. So for the next questions, right, if you see the area of the shaded region, how do we find the area of the shaded region? Yes, we will have to find area under the curve. Then minus away area of this triangle here. This one we can't use the shortcut I've just mentioned earlier on because the limits are not the same. If you look at the limits for the triangle, Okay, it's from here to here. And the limits under the curve is from there. So we have 3 different points, unlike the previous one. So here we can't do the shortcut. We will have to find area under the curve and then minus away area of the triangle. Right, but first we have to find all the x coordinates. So to find the x coordinates, let's see what we are given. We are told that the tangents at point P, this line here, the gradient of that particular tangent line is 4. So what we need to do is we need to find our gradient function, which is what I found here. The gradient functions, equate it to 4. You can do a cross multiply. (32) divided by 4 will give you 8. You cube root 8 will get 2. So you have 5 minus x equals to 2. So x therefore will be 5 minus 2 gives you 3. So that explains my answer here. So the x coordinate of your point P will be 3. Okay, we are not interested to know the y coordinates because we need to know because we need to find area of the triangle. So to find the y coordinates, you just need to substitute x equals to 3 into the equations of the curve. And that gives you 3 also. Alright, so we have found the coordinates of point P, which is part I. The next thing is that I need to find point Q. And that is when I let y equals to 0. So I would end up getting 16 over 5 minus x to the power of 2 equals to 1. You do a cross multiply. This is what you get. It can be positive 4 or negative 4. So x can be 1 or 9. But of course, the x coordinate of Q will have to be less than the x coordinate of point P. So therefore, point Q will have to be, x coordinate of point Q will have to be 1. This will have to be rejected. So that explains my answer here. So the equations of PA would be, since I've already found point P, and I will also know that the gradient is 4 given here, I can just generate the equations of PA. And why do I need to know the equations of PA? Because I need to find the x coordinate of point A. So I'm going to let y equals to 0. If you let y equals to 0, you will have 4x minus 9 equals to 0. X will be 9 over 4. So that will give you point A to be 9 over 4, comma 0. Alright, we're going to keep that. So right now we're going to find area under the curve. That's from this part here. This is what we're interested to find. This is an area under the curve here. So we're taking limits from 1 to 3. So that explains this part here I'm going to do. Okay, this one here will give you 16 bracket 5 minus x to the power negative 2. If you were to integrate it, that will give you 5 minus x to the power negative 2 plus 1 gives you negative 1. Divide by negative 1 times differentiate 5 minus x will give you negative 1. So that will give you 16 times 5 minus x to the power negative 1. That gives you 16 over 5 minus x. So that explains this part here. Okay, now we can put in the limits. So the area under the curve from x equals to 3 to x equals to 1 will be 2 units square. So the next thing is that I need to find area of the triangle from x equals to 3 to x equals to 9 over 4. Here, the x, this one will be 9 over 4. And this is 1. And that will be half base times height. And that gives you 9 over 8. I'm going to use the area under the curve, which is 2 minus 9 over 8. And that gives me area of the shaded region to be 7 over 8 units square. Right, let's look at the next question. This is the second last question. So if you're losing steam, do take a break. We'll be ending this assignment very soon. And also congratulate yourself for having stayed on so long. So for this question here, there's a hint given. Is there a line of symmetry? Right, if you examine this questions, this diagram, if you were to draw a vertical line here, oops, that's not a vertical line, that's a crooked line. Sorry. I'm going to draw a vertical line which is parallel to the y-axis. We can see that this area is the same as this area, right? So there's several x coordinates we need to find, x coordinates of A, B, C, and D. All right, so we're going to find, of course, the x coordinates of A will be 0. So we're going to substitute x equals to 0 into equations of the curve, and you can find point A. And to find the rest of the other x coordinate, we let y equals to 0. So there will be two possible values for x, negative 5 and negative 1. So of course, the x coordinates of B will be the one bigger, negative 1. And for C will be negative 5. And how do we find the x coordinates of point D? You'll see that since we agree that this area is the same as this, they're identical, right? So this distance here will be the same. So we found the x coordinate of B to be negative 1. So in other words, this will be 1 unit. And therefore, from here to here will also be 1 unit. And hence the coordinates of D will be negative 5 minus 1 gives you negative 6. So the x coordinate of A, B, C, and D will be 0, negative 1, negative 5, negative 6 respectively. Okay, you have to answer your questions in a professional manner to get the full marks. Alright, so for part 2, find the area bounded by the curve AB and the coordinate axis. Meaning this one that we need to find. So we need to integrate the curve, taking limits from taking limit from negative 1 to 0. And you end up getting 1 unit square. That's for part 2. Alright, then to find the area of the shaded region, so we we did agree that these two will have the same area, right? So we just need to find the area of the rectangle minus away part 2 times 2. So area of the rectangle will be this distance here, which is 6 units. because the coordinates of D is negative 6, 0, so 6 units. And then we found the coordinates of A, right? The y coordinate is 5 over 3. So this part here is 5 over 3. So it's just 6 times 5 over 3 and then minus away. Oh, minus away 2 units, not 1, sorry. Because this is 1 here, this is another 1. So that is an error here, minus 2. So the answer will be 8 units square. Right. Right, we've come to the last questions. So, but the last question is also one of the more challenging one. And in this questions here, we are asked to find the area of the shaded region. But before we do that, we need to find the coordinates of point P, which is in terms of K. We need to show that, prove that K is equals to 1. But we are given some information here. What are the informations given? We are told that there is a tangent line, PT. PT is a tangent line. And that's a normal line. So PN and PT are just 90 degrees to each other. Okay, and we're told that the normal line actually makes the x-axis at this particular point N here. And we're also told the coordinates for x. Right, so what else can we do here? What is this topic all about? It's all about differentiation and integration, right? And if you're talking about tangent line, what is it that we need to find? Yes, we need to find the gradient function, right? And where do we get the gradient function? That is when we find your dy dx. Alright, and how do we make use of the dy dx? How is your gradient of the normal related to gradient of your tangent line? Yes, these two gradients must multiply together to give you -1, right? So I'm going to find gradients of your normal line, which is gradient of Pn. y2 minus y1 over x2 minus x1. That is easy. And this gradient will be equals to -1 divided by your gradient of your tangent line. Right, gradient of a normal is equals to -1 divided by gradient of your tangent line. Negative and negative divide will give you positive, right? Flip your flip your algebraic fraction. So this explains how I get this value here. That value is -1 divided by the gradient of your tangent line, which gives you the gradient of your normal line. And we're going to do a cross multiply. Okay, and then put everything on the left hand side, factorize your square root 7 minus 3k. Okay, then you factorize this guy out. So you end up with k plus 5 minus 6, which is plain here. Okay, we need to reject this value. Why? Because you're told in the questions that k is less than 7 over 3. So therefore, we reject k equals to 7 over 3. So therefore, k is equals to 1. Proved. So that's part I. So once I know k is 1, I can substitute into p here to find my p to be 1, 4. So what is important? Why is that important? It's because they will help us to do part 2. Part 2, we asked to find the x coordinate of t. We asked to find, right, so t lies on your tangent line. So once I know that x coordinate of P is 1, I can substitute into my dy dx to find my gradient. I'm going to let t to be called as a comma 0. So I can find gradients of pt, which what I've just mentioned just now, by substituting x here to be 1. I'll get negative 3 over square root 7 minus 3. And that explains how I get negative 3 over 2. I can go on to find the equations. Oh, I don't need to find the equations. I can just use the gradient formula, which is y2 minus y1. Since I'm going to let t to be a comma 0, right? I can just use y2 minus y1, that's 4 minus 0 over 1 minus a. And my gradient is equal to negative 3 over 2. And then do a cross multiply, I can get a to be 11 over 3, which is exactly what I'm supposed to show in part 2. If you don't want to do it this way, of course, you can go on to find equations of your BT. Equations of BT, which is y minus 4 equals to negative 3 over 2, x minus 1, generate the equation, and then let y equals to 0 to find your x coordinate. But that will be slightly longer. So the method that I've shown you is neater. Right, so we've come to the last part of the questions, and that's to find the area of the shaded region. So let's put in all our x coordinate. So the x coordinates for x will be 7 over 3, 0, and then for z will be 1, 0, because z is vertically below p. So they have the same x coordinates as p, which is x equals to 1. Alright, so to find the area of the shaded region, we need to find the area of your triangle PZT, then minus away area under the curve PZX. So let's find area under the curve for PZX first, taking limits from 7 over 3 to 1. Alright, so simplify this. If you use your calculator, if you take 2 divide by 3 over 2 times bracket negative 3, use your calculator correctly, you get negative 4 over 9. So that explains this part here. And then substitute in the limits for x to be 7 over 3 and 1. Use your calculator, do it correctly, you get 32 over 9. The next thing is to find the area of a triangle, PZT, half base times height. This will be 4. And that will be 11 over 3 minus 1. Give us 16 over 3. So we're going to use that to minus away area under the curve we have found to be 32 over 9. And that gives us area of shaded region to be 16 over 9 units squared. And so with this, it ends our assignment 17.2. So happy learning.